Hey guys, Miss Marflack here. We're going to graph our log function in this video, and throughout this whole video, our log function will not have transformations. So you will see another video where we do have transformations, but for right now, we're just graphing our log function with different bases. We're going to start off just kind of refreshing our memory with that definition that we do have a few conditions for that base, which we're really looking at, and that's that our base has to be greater than 0. It cannot be a negative number. And then also our base cannot be equal to 1. Thinking about how we write in exponential form, when I do b to the y is equal to x, well, if my base is 1, 1 raised to any power is 1. So it won't look like a log function. Instead, it'll just be a straight constant line. So those are our conditions. We're going to go ahead and we're going to start with this first one, and that is our base 2, and that's our most popular. Besides our common log, we usually start off with graphing our base 2. Now, I know you may have seen this very, very briefly in class for my academics, and then for my honors, we did see this in our introduction to log video. All right, but that's okay. We're going to start with this one again, and we're going to draw those arrows. If you're not comfortable with it by now, you should be feeling very, very good going into that exponential form, and that's 2 to the y is equal to x. So I'm going to rewrite this here. 2 to the y is equal to x. Now, when we graphed our exponential function, we choose the power because we want to raise a number to that power and then get out an answer. Now, these were switched with our exponential function, and now they're switched with our log function. So instead of choosing x, we're going to be choosing y now. So that's the main difference. We're choosing those y values. Now, if you can remember, we always use the y values -2 to 2 whenever we didn't have a transformation left and right. And you can see in this video, we're not having any transformations. So I'm picking those y values -2 to 2. That's the key here. All right, and then now that we have those y values, we can plug them into the function, and 2 to the -2, well, that's 1/4. 2 to the -1 is a half. 2 to the 0 is 1. 2 to the first, and then 2 squared. Now, I did those really quickly. If you need to take your time, that's a-okay. Pause the video, and then try it on your calculator. All right, if you can't do those property of exponents in your head, that's okay. Put in your calculator 2, put the little caret, parentheses, -2, parentheses, and you should get out 0.25. Or you should get out 0.5 here. All right, but I'm going to keep it going with the fractions, and then I will upload here a blank PDF for those of you who do have printers. If you don't have a printer, that's okay. Go off to the side and just do a really rough sketch for our coordinate plane. Now, I pre-graphed these. That way we can talk about them. If you want, you could pause the video and take your time with graphing them. Here's our first function graphed. I have that point there at 1/4 -2, 1/2 -1, 1 0, 2 1, and 4 2. We have this nice curve here, all right, and this arrow is going to keep going all the way down. We need to have arrows on both ends of our function. And then I just labeled here for us that this is our log base 2 of x is equal to y. So there's the first one graphed, and now we're going to move on and we're going to take a look at another one. Here we are, number 2. We're going to have a log base. We're going to increase our base. We're going to have log base 6. All right, we're going to scoop and loop around, and we're going to write this in our exponential form, and that's going to be 6 to the y is equal to x. So we're rewriting this here. 6 to the y is equal to x. Once again, we have no transformation, so we have not shifted left or right. So we're starting off with those y values, -2 all the way to 2. Plugging in our -2, we get 1/36, 1/6, 6 to 0 is 1, 6 to the first power is 6, and then 6 squared is 36. All right, double check that on your calculator and make sure that you are able to get out those values. And then now we're going to take a look here at our next graph. I did graph our points already for us. So we have 136. We're a little closer to that y-axis, -2, 1 6, -1. Still have that point 1 0, which is interesting. And then here we are at 6 1, and then 36 2 is way off the page, so we're just going to leave that one out. And then I just labeled this for us here that this is our log base 6 of x is equal to y. If you don't have that down, pause the video. If you do, we'll keep moving on here. All right, and then the last one we're going to graph here with a whole number base is going to be our common log. All right, now I keep writing the y on this side. It doesn't have to be on this side. It could be on the other side. all right? But you should be feeling, you know, really comfortable going into that exponential form in either way, and we're going to have 10 to the y power is equal to x, scooping and looping around. So I'm going to rewrite here 10 to the y power is equal to x. And then now same thing, no shifting left or right, so we're picking those y values, -2 all the way to +2. All right, and then once we have those y values, we're plugging them into the function here, plugging them in, and I have 10 to the -2. Well, that's going to be 1 over 100. 10 to the -1 is 1 over 10. 10 to the 0 is 1. 10 to the first is 10, and then 10 squared is 100. All right, and then just kind of like, you know, number 2, we do have a point that's going to be off the page. That is a-okay though. But you can see that our graph gets a little tighter to that x-axis. All right, I did graph our points here. 1/100th, -2, 1/10th, -1, 1, 0, interesting. Again, we still have that point, and then 10, 1 is way off the page. All right, so here is our last one that we're going to do with a base that is a whole number, and then now we're going to talk about characteristics. So we're going to move back here to our notes page, and I'm going to title right here, characteristics. Now, keeping in mind that these characteristics that we're listing out here are only characteristics of our function with no transformations. All right, these characteristics will not hold true once we start shifting these graphs left, right, up, down, and start doing some reflections. Kind of going back and forth, you should be glancing back at your graphs. There's a few things that we noticed. The first thing I noticed is that these graphs all approach 0, all right, but they don't touch 0. And you can see that in the table of values as well. We get these fractions that just get smaller and smaller, but our x is never 0. So that means that we have our vertical asymptote that's kind of bounding us there, and that vertical asymptote is going to be at x equals 0. Now, if you can recall, when we did our exponential function, we had a horizontal asymptote at y equals 0. All right, another thing we're going to take a look at is our domain and range, seeing where our function is defined on. And you can see with all of these graphs, looking at domain, keeping in mind domain is your x values that you're defined at. We start at 0, and then the arrows goes out to infinity. Same thing, starting at 0, arrows go out to infinity, 0, out to infinity, which means that our domain is 0, non-inclusive, okay? We can't have it equal to 0, and then out to infinity. Now, I know my Algebra 2 academics, maybe we haven't seen interval notation. That's okay. This is the same thing as saying x can be greater than 0. All right, now we're going to take a look at our range. And what's interesting is that we do have arrows on both ends of our graph here. So this graph keeps going down, down, down. And also, even though it looks like it flattens out here, it still keeps growing. And you can see that from the table of values. When, you know, y is 2, we're going to have 100. When y is 3, we're going to have 1,000. So these are going to grow so slowly, but they're still going to keep going up. So we have from all the way to the bottom, from all the way to the top, and that's going to be -infinity to +infinity. And then for my Algebra 2 academics who are not comfortable with the interval notation, this is like saying y can be any number. It can be any number. And then the last thing I kind of noticed here is that we're all going through the same point, and you could see that that's going to be what we call our x-intercept, and that's through the point 1, 0. And then if you remember with our exponential function, that was switched. They all went through the point 0, 1. And then by looking at these graphs, hopefully we notice a pattern here, and we're going to talk about when our base is greater than 1. As our bases increase, okay, so we're increasing here 2 to 6 to 10. As our bases increase, this graph kind of looks like it starts compressing, and it gets closer and closer to the x-axis. So we're just going to write that down here as another characteristic, and that's going to be when b is greater than 1. As b increases, we have, I guess I could put compress, but what I really want to say here is that our graph gets closer to the x-axis. And that's definitely something that maybe you could see as like a fill in a blank on a quiz or something like that. You could see, I can ask you, you know, when b is greater than 1 and our bases start to increase, what happens to our graph? And you could see your graph gets closer and closer to your x-axis. All right. We're almost done here, but I do want to graph some bases that are decimals. So that's what we're going to do now. Should I flip onto the back? No, we'll go onto another sheet. And we're just going to do 2 more. So we did 1, 2, and 3, and here we are. We're going to take a look at number 4. And then now we're going to do our base is going to be a fraction or a decimal. So we're going to have log base 0.5 of x. So we're going to scoop and loop around, and that's going to be 0.5 to the y power is equal to x, or you can rewrite this as 1/2 to the y power is equal to x. Same thing here, no shifting left or right, so we're picking those y values, -2 all the way to +2. Plugging it into the function, 1/2 to the -2, well, that's going to be 4. 1/2 to the -1, that's going to be 2. If you don't know that, if you don't know how to do the property of exponents, use a calculator. And then 1/2 to 0 is 1. 1/2 to the first power is 1/2, and then we have 1/4 here. I should have graphed this one, but I didn't. Okay, that's okay though. I'm going to come up over here off to the side, and I'm going to graph at number 4. I'm trying to get both the graph and the table in our little picture here. All right, so this is going to be our log base 0.5 of x, and we have our x value is 4, our y value is -2. Our x value is 2, our y value is -1. We still have this 1, 0, then we have 1/2, 1, and then 1/4, 2. And you can see this looks a little funny here, okay? But it kind of looks like our graph just reflected over the x-axis. All right, if you don't have this, pause the video. If you do, we're moving on, and this is going to be the last one we're graphing. Yay, you're almost done. And here it is, number 5. And we're just going to increase the base a bit, and we're going to do 0.8. Now, you could do 0.8 as a fraction if you'd like. When you scoop and loop around, you could write this as 8/10 and then simplify that to 4/5 and then do the property of exponents. But Ms. Marflek got a little lazy towards the end, so I just used a calculator, and that's okay. All right, still sticking with those y values, -2 to 2. Plugging it in on the calculator, you should get out, 1.56, 1.25, and then we just keep going down here, 1, 0.8, and then 0.64. All right, those are our values taken from a calculator. Here's number 5 and graph number 5. This is our log base 0.8, and then we have of x. So we have, 1.5, we got -2, here we have 1.25, -1, 1, 0 again, 0.81, and then a little bit more than 1/2, we have 2. Now, it may look like a straight line, but we got to know the shape of the function, okay? We know that this is the shape, and we know we got that vertical asymptote, so we're going to do the same thing here, and we're going to still do that nice log shape, okay? So I'm not just connecting a straight line there. All right, and then now we're, we have the same characteristics as before. We still have, when our base is less than 0, we have these characteristics. When our base is between 0 and 1, I should say, we still have these characteristics: vertical asymptote, domain, range, and x-intercept. And then now we're just going to have a little bit different start here of something that we notice, and that's going to be when our base is no longer greater than 1, but instead it's between 0 and 1, kind of like this decimal here, as our base increases. So from number 4 to 5, our base did increase. It went from 0.5 to 0.8. Instead of having a compress, now we have like this stretch. And I should say that we get further away from the x-axis, away from the x-axis. And then you could see here, just kind of going back to those two graphs. I wish I graphed them side by side, but I didn't. Here's 4. It's a little closer to the x-axis, and then as the base got bigger, we're a little further away from the x-axis. All right, make sure if you're my honors class, you're checking out the next video, and then you're doing your homework because we're also going to graph now in the future log with transformations. Okay, email me if you have any questions, and at any time you can kind of go back to the video and check and make sure you have down all of these notes. And once again, if you don't have a printer, that is okay, but you still should really have these log graphs in your notebook. All right, keeping in mind that we would probably still have finals, so you'll definitely see logs on your finals, and I want to see everybody taking good notes. All right, bye guys.